All right, hi everybody. We're working through the diploma prep material. This is the chapter on exponents and logarithms, and we're going to solve a logarithmic equation here. Now, a colleague of mine once watched me do this and commented to me afterwards that really what I should be doing is encouraging people to just bring all the logarithms to one side and taking all the constants to the other. That's a much simpler way to approach this, and he was right. Okay, there are ways that you can make this, like with different forms of the equation, quicker, but if you want one method that just basically works, what he suggested is correct here. Bring the logs to one side and then combine them into one logarithm here. Now I've seen students try to distribute the log, okay, across the binomials in here, but you can't do that. There is no rule that says you can do that, okay? So what you have to do here is don't distribute. If you end up with more logs than you started with, you're doing it wrong. Okay, you're doing it incorrectly here. What needs to happen here is that addition, okay, needs to become multiplication. And so already in this first step, I've got it from 2 logarithms to 1 logarithm. Then what I'm going to do is I'm going to get rid of the log by converting this to exponential form. So this is going to become 4 to the power of 2, or well, we'll do it as 4 to the power of 2, and that will equal x plus 2 times x minus 4. Now, could I have expanded the binomials out first before I did this? Yeah. But my goal here is to remove the logarithms. So bring all the logs to one side, combine into one logarithm, get rid of the log, okay, by converting forms. Now, this is just a quadratic, okay? I'll expand this out. This is 16 is equal to x squared minus 2x minus 8. I'll bring the 16 over, so I'll get x squared minus 2x minus 24. Now it's a quadratic. I'm going to factor this and I'll get x minus 6, x plus 4. So my solution is either going to be positive 6 or negative 4. Now, to check your answers, now don't just immediately assume that the negative is incorrect. You got to go back up and check here. If you plug a 6 into the original expression here, 6 plus 2 is 8. Can I take the log of 8? Yep. 6 minus 4 is 2. Can I take the log of 2? Yep. Negative 4. Negative 4 plus 2 is negative 2. Can you take the log of a negative? No. So in this case, I am ignoring the negative, but that is not always true. And so you do have to check it.